Here we wish to graph the function y equals 4 times the sine of the quantity 3 times the quantity t minus pi over 2 quantity plus 5. Now this is just a review preliminary to a test that's coming up. Review a question asked by a student regarding a graphing assignment. So, how do we graph this function? Well, we determine the amplitude A, which is the function, the coefficient out in front of the sine. We're going to determine, well, omega is going to be 3. Remember, omega is the number of radians per second at which we go around the reference circle, or the number of radians per unit time. We got an h equals negative pi over 2, and we'll deal with that a little bit later, and we have c equals 5. Now we're going to ignore the h for the moment, but we will note that h is pi over 2. And we're going to simply graph y equals 4 times the sine of the quantity 3t plus 5, because this fits into our circular model in a fairly simple way. Then we'll incorporate the negative pi over 2 in a couple of ways. Again, please forgive the scratch out here. A is the amplitude, the distance between the central point and the peak, or the central axis and the peak, or the valley of the sine function. And that's going to correspond to the radius of the reference circle, as we should know very well by now. C equals 5 tells us that this sine function here oscillates around y equals 5. So that we're going to center our reference circle at y equals 5. So we have a reference circle of radius 4 centered at y equals 5. And here's the model of our graph. Omega equals 3 tells us that we're moving at 3 radians per unit of time around this circle, and that the period is therefore the 2 pi radians in a circle divided by the 3 radians per second at which we travel around the circle. So that the period is 2 pi over 3, so that if we start the sine function, the cycle of the sine function here at t equals 0, the period will end at t equals 2 pi over 3, little t equals 2 pi over 3, corresponding to the period big T equals 2 pi over 3. Taking the value of h into consideration, h equals pi over 2, and that therefore corresponds to a shift of pi over 2 units in the t direction. Remember that when we replace t by t minus h, that shifts the graph t unit, or h units in the t direction. So that this graph, which goes from 0 to 2 pi over 3 in its first cycle, excuse me, will have to shift pi over 2 units to the right. That means we'll shift the starting point pi over 2 units. Now how big is pi over 2 in this graph? Well, if we break 2 pi over 3 into 4 equal segments, each segment will be 1/4 of 2 pi over 3, which is 2 pi over 12, or pi over 6. So we got pi over 6, pi over 3, pi over 2, 2 pi over 3. Pi over 2 then occurs right here, 3/4 of the way between 0 and 2 pi over 3. So that when we shift pi over 2 units, that shifts the starting point of this cycle to here. So we're at y equals 5 and starting to move upward, and that point is here at pi over 2, where we're at y equals 5 and starting to move upward through the cycle. The rest of the cycle just shifts to the right accordingly.